So, let's solve a little mystery, shall we? It's the case of the red-stained water. You know what I'm talking about. You look at your sink or your tub, and you see these stubborn, rusty red stains. But when you turn on the tap, the water comes out looking perfectly crystal clear. So what in the world is going on?
Yeah, that's the sight. It's so frustratingly familiar, isn't it? And if you have well water, you are probably nodding your head right now. You see it on your fixtures, in the toilet bowl, maybe even on your freshly washed clothes. The water looks totally pure, but it leaves behind this calling card.
And that really is the central puzzle here. How can something that appears completely clean be the culprit behind such a persistent, colorful mess? Well, the answer lies in a little bit of chemistry, and it involves an element that's dissolved in your water, making it completely invisible to the naked eye.
And get this is the really wild part. It takes next to nothing to cause these stains. We're talking a concentration of iron as low as 0.3 milligrams per liter. That is less than 1 part per million. It's an incredibly tiny, totally invisible amount that has a very, very visible and annoying impact.
Okay, so let's pull back the curtain and finally unmask this invisible culprit. It all comes down to the secret life of iron and what happens when it has a very dramatic run-in with oxygen.
So here's the secret. Iron kind of has a split personality. When it's underground, tucked away from the air, it's in its ferrous state. Think of this as the invisible stowaway. It's completely dissolved, totally colorless. But the second that water comes out of your tap and hits the air, it transforms into ferric iron. And that is our rusty troublemaker. It's a solid particle, and it is no longer invisible. And this breaks down that transformation perfectly. So underground, the water's clear, carrying its secret stash of dissolved ferrous iron. Then, at your tap, boom, it meets oxygen. That contact kicks off a chemical reaction called oxidation, which is just a fancy way of saying the invisible iron turns into visible, solid rust. And the result? Water that gets cloudy and leaves those stains everywhere.
And look, this quote from the source material just sums it up perfectly. It's clear when it first comes out of the ground, but once it gets a gulp of air, the change begins, and you start to see that telltale reddish-brown color.
So you might be wondering, okay, if it's a solid particle now, why doesn't it just sink to the bottom of my glass? Great question. The answer is a pretty cool scientific phenomenon called a colloid. It's the same reason milk looks milky. The tiny particles are so small, they just hang out, suspended in the liquid.
So how does that work? Well, each one of these tiny rust particles has a negative electrical charge. You can think of it like they all have their own little force field. They're constantly pushing each other away, which keeps them from clumping together and getting heavy enough to sink. So they just float, giving your water that reddish tint.
But believe me, this problem is so much bigger than just some ugly stains. That's really just the tip of the iceberg. Let's talk about the hidden costs and the not-so-hidden consequences of having all this iron in your water. And first, let me just make this super clear. This is not a health issue. Drinking this water is not going to harm you. But it is officially classified as a major nuisance, and that's because it can set off a whole chain reaction of really expensive and frustrating problems throughout your home.
And it really is a domino effect. It starts with stained laundry, but then it moves on to blocking your pipes and killing your water pressure. It can even make your water pump work harder, which drives up your energy bills, and in the long run, it can cause your expensive appliances to fail way sooner than they should.
Oh, and let's talk about your morning coffee. The metallic taste is bad enough, right? But it gets worse. The iron reacts with compounds called tannins, which are naturally in coffee and tea, and it creates this nasty black sludge. It totally ruins the flavor and the look of your drink.
And just when you thought it couldn't get any worse, it does. Turns out iron-rich water is like an all-you-can-eat buffet for something called iron bacteria. Yeah, these are actual living organisms that feed on the iron, and they create this slimy, foul-smelling orange-brown gunk that can clog up your whole system. So it's not just a chemical problem, it can be a biological one too.
Okay, enough of the bad news, because the really good news is that this is a totally solvable problem. So let's shift gears and talk about the strategy. Let's talk about how to fight back against the rust. The overall strategy is actually really simple and kind of brilliant. It's a two-step process. First, you have to oxidize it. You basically force that invisible dissolved iron to become a solid particle. You're actually speeding up the very thing that causes the stains in the first place. Then, once it's solid, step 2 is easy. You just filter it out.
And this shows a couple of common ways to get that done. On one side, you've got oxidation filters, which cleverly do both steps in one unit.
On the other, you have adsorption filters. These use materials with a massive surface area, like activated carbon, that basically act like a magnet and just grab the impurities out of the water.
This chart gives us a fantastic look at the different tools in the toolbox. You've got oxidizing filters, which work great if your water has a neutral pH. Then there's ion exchange, which is what a typical water softener does, and that's best for water that hasn't been exposed to oxygen yet. And for really tough cases, you might even need to inject an oxidant like chlorine to force the iron into a solid before you filter it.
And listen, if you take one thing away from all of this, let it be this. There is no magic one-size-fits-all solution here. The absolute best treatment for you depends entirely on your water's unique chemistry. You have got to get your water tested to figure out its pH, its alkalinity, and exactly how much iron you're dealing with before you can choose the right system.
And with that, our case is closed. We started with a simple, annoying stain and uncovered a whole story involving chemistry, physics, and even a little biology. So it leaves us with one final, thought-provoking question. Now that you know the secret behind the stains, what other invisible culprits might be hiding in your water?